Hi, welcome back. This is now 11.3. We're going to worry about graphing the quadratic function. Okay, and basically all these are parabolas. I think I accidentally thought you already knew how to do this, and I mentioned that in the video on radicals, but I don't think you actually have done this before. So quadratics and their graphs. Okay, so what do they look like? They look like kind of like horseshoes. Okay. Or a U if you want to. They characterize this as being concave up. Okay. Anyways, it'll look like a big U. It should be symmetric about this line right here, which is called the axis of symmetry. Okay, so this is the axis of symmetry. And this point on the graph right here is the vertex. And we usually give the vertex the coordinates h comma k. So we call the x-coordinate of the vertex h, the y-coordinate k, right? And of course this is the axis of symmetry. Okay, and this thing is the graph of the function y equals ax squared plus bx plus c. And we can find the vertex by using this kind of looks like the complete the square formula, but it's not. The vertex will be located at negative b all over 2a, comma f of negative b over 2a. Okay, so this concave up version is when the a value, the leading coefficient, is positive. Okay, it'll be concave down, or kind of upside down if you want, in this direction, when the a value is negative. So I shouldn't have put 1, I should put greater than 0. So as long as it's positive. Okay. And in this case, the second case, that's when the a value is less than 0. Again, the vertex will be given with the location name h comma k. There'll be this axis of symmetry going straight through that point. Okay. So the axis of symmetry is always going to be axis of symmetry is always going to be given by the formula x equals, and then we just use the x coordinate of the vertex, the negative b over 2a. The domain is all real numbers, and basically the domain just says whatever you can put in here. So there's no issues with square roots or dividing by 0. So the domain is anything. Anything goes, negative infinity to infinity. The range is dependent on the a value. So if you look at the two graphs, on the first graph, the range is going from this point on and on and on up. Okay. If you look at the second graph, the range is basically going in the other direction all the way to the top of the parabola. Okay, these things are called parabolas. Okay. So the range is dependent on the a value. So if the a is greater than 0, then your range will go from the y coordinate of the vertex, which is f of negative b over 2a, to infinity. And then if the a is less than 0, it'll be the second case, and basically you'll be going from negative infinity all the way up to the y coordinate of the vertex. Okay, so that's a lot to stomach, I know, but that's pretty much in a nutshell everything we need to have. There's one other version of the formula for the parabola, and the other version is this kind of easy to read the vertex off of formula, I guess I'll call it. Y equals a times x minus h squared plus k. The a is the same value of a from above. The good thing about this is you could see the vertex on the function without having to do any tricky formulas. Okay. Just one note on this thing: if you have something like y equals, so some examples here, y equals 3 times x plus 7 squared minus 5, the vertex in that case is going to be, you have to take like the opposite sign. So if it's plus 7, it's really going to be minus 7. And then it says minus 5, so you have to go, well, you keep that one the same. That one will be minus 5. Okay. Let me give you another example. Hopefully that'll be clear. So this one you have to change to the opposite. The other one you keep the same. Okay. Y equals 2 times x minus 7 squared minus 3. So in this case, the vertex would be 7 comma negative 3. Okay. Let's get another. Y equals 2 times x minus 3 squared plus 1. Okay, so this is kind of your standard vertex form. You could just read off the answer 3, 1. Okay, so take the opposite sign of the first one, keep the second one the same. One last. Y equals negative 3 times x plus 2 squared plus 5. Okay, so again, take the opposite sign of the first one and then leave the second one as is. Okay. Okay, so hopefully that clears that issue up. Let's work with graphing this now. I kind of have a procedure I want you to follow on the test, and I'll remind you of everything I want once we get to the test here. Times x minus h squared plus k. Okay, so first I want you to identify, is it, concave up or concave down? And all you have to do is write, if a is greater than 0, then it's a happy face. Or is a less than 0? In that case, it's sad face. Okay. Secondly, then, get the vertex, which you can find just by reading it off the formula. Thirdly, get the domain, range, and axis of symmetry. Fourthly, get the X and Y intercepts. Okay. So let's take a look. Here we have number 10. F of x equals negative 3 times x minus 2 squared plus 12. Okay. So first, the a value is negative 3. That's less than 0. So therefore, it's a sad face. 2, the vertex. So it's the same sign, or opposite sign, sorry. So instead of negative 2, it's positive 2. And then keep the 12 the same, plus 12. Thirdly, the domain is always going to be negative infinity to infinity. The range will always be based off the type of sad face or happy face. So if it's sad face, it's going from negative infinity all the way up to the y value for the vertex. Then the axis of symmetry, will be x equals the x coordinate of the vertex. So that'll be x equals 2. Then fourthly, get the domain, the x and y intercept. For the x intercept, you let y equal 0. Okay, so I'll have 0 equals negative 3 times x minus 2 squared plus 12. And then we have to solve this. Okay, so move this item to the right, or sorry, to the left. You get 3 times x minus 2 squared equals 12. Divide both sides by 3, and then you could use the square root property. So we get x is 2 plus 2 or 4, or 2 minus 2, which is 0. So our x-intercepts 4, 0, and 0, 0. For the y-intercepts, you let x equal 0. Okay. So going back to the original expression, I got negative 3, or f of x equals, I'll just put y equals negative 3 times 0 minus 2 squared plus 12. Okay. So I'll have y equals -3 times -2 squared is 4 plus 12. So y equals -12 plus 12 is 0. And so our y-intercept 0, 0. Okay. Now we have all of our information and we can go ahead and graph it. Okay. So the vertex is 212, so I'm going to make it real big in the first quadrant for us. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is the vertex. That's also where our axis of symmetry is going. And then the y-intercept is 0, 0. And then we have an x-intercept there as well on the same point. And then 4, 0 for the other x-intercept. And then we can connect the dots, and it should be symmetric about the line of symmetry. Okay. Whoa, that was a nightmare. I didn't mean to do that. Let's try that again. I'm trying to make it as symmetric as possible. It's just not working. Okay. Let's move on. Let's try another one. So here's 22. Get y minus 3 equals x minus 1 squared. Okay, so first I'm going to put it in the appropriate form, move the 3 to the other side, and now I can start getting my information. So first, the a value is 1. It's greater than 0. In other words, that's a happy face. The vertex, I could read straight off the graph, so opposite sign and then same sign. Domain is always the same, -infinity to infinity. The range, because it's a happy face, I start at the y-coordinate of the vertex and then go to infinity. The axis of symmetry is always x equals the x-coordinate of the vertex. Finally, the x-intercept. For the x-intercept, you let y equal 0. Again, I could just use square root property. So I'm going to move the 3 to the other side, flip-flop the equation. And here you don't have real solutions. So when that happens, you don't have any x-intercepts. Okay. And you could just leave your answer like that. The y-intercept, so here you're letting x equal 0. So y equals 0 minus 1 squared plus 3. So y equals -1 squared is 1. So y equals 4. So my y-intercept is at 0, 4. Okay, so I got all my information. I can go ahead and graph it. So 1, 1, 2, 3 is where the thing lives. It has a y-intercept of 4. And then here's our axis of symmetry at x equals 1. And it should be symmetric. And it's concave up. Okay, let's try one with a fraction, just because those are so annoying. Okay, I'm going to rewrite this so it's in our sort of standard form. And now I can start getting my information. So the a value is -1, it's less than 0, so you have a sad face. Okay. Secondly, I need the vertex. So opposite of -1/2 is +1/2. Then the same sign is 5/4. Okay. Our domain, always -infinity to infinity. Our range, because it's a sad face, it's going to go from -infinity all the way up to 5/4. And the axis of symmetry, x equals 1/2. Okay. Finally, the x-intercept. For the x-intercept, you let y equals 0. So I'll have 0 equals -x minus 1/2 squared plus 5/4. I'm going to move the x minus 1/2 squared to the other side and then use the square root property. So it'd be square root of 5 over square root of 4. Square root of 4 is 2. I need to be able to plot these, so I'm going to get some decimal approximations. 1/2 plus square root of 5 over 2 is about 1.62. 1/2 minus square root 5 over 2 is about negative 0.62. Okay. Then I'm going to get my y-intercept. So if you're a y-intercept, you let x equal 0. Negative 1/2 squared is 1/4. Negative 1/4 plus 5/4 is 4/4, which is 1. And that'll be my y-intercept at 0, 1. Okay, so now we should be able to graph this thing. Let's see what happens. So here's 1, 1, 2, 2, negative 1. Okay, so let's see, the vertex is at 1/2, 5/4, about right here. The x-intercepts 1.62 is about right there. Negative 0.62 is about right there. And then 0, 1 is about right here. Axis of symmetry going through the vertex. And then we could go ahead and do our drawing. Should be symmetric, but you know, trying the best I can. All right. All right, now we want to do the other form. Okay, so we just did this form here. Sometimes I call it the vertex form. I've seen it called the standard form as well, but I kind of think of this one as a standard form. This is the one we want to do next. Okay, so the procedure is pretty much the same except for the vertex, and so you have more work to do there. Okay, so first, identify the a value. If it's greater than 0, it's a happy face. Less than 0, it's a sad face. Get your vertex, and this is where you have some work, right? So the h coordinate, and the vertex is always h comma k. H coordinate will be negative b over 2a. You need to have these formulas memorized. And then the k, basically just put this back into f of x. So it'll be f of negative b over 2a. It's just like when somebody gives you an x coordinate and you need the y coordinate, you just plug it into the equation, okay, for your xy table. Then thirdly, your domain is always the same, negative infinity to infinity. Your range, though, is going to depend on the type of graph again. So if it's a happy face, you'll have k to infinity. If it's a sad face, you'll have negative infinity to k. And then the axis of symmetry, of course, is always going to be x equals h. And then finally, get your x and y intercepts. And sometimes the x-intercept can be a nightmare because you may have to use a quadratic formula. Okay. So let's take a look at a couple of these guys. And we'll try 28. So f of x equals x squared minus 2x minus 15. And so first, the a value is 1. That's greater than 0. That's a happy face. The vertex, the x coordinate is negative b, so negative negative 2, all over 2 times 1, which will be 2 over 2, which is 1. Then you take the 1 and you plug it into the f of x to get the k formula. So it's going to be 1 squared was 1, minus 2 times 1 is 2, minus 15. So I get negative 16 for my y coordinate. Oops, I screwed that up. Yeah, I screwed something up. Maybe I copied it now. No, I'm right. I'm good. Thirdly, the domain, of course, negative infinity to infinity. The range, because it's happy face, it's going from negative 16 to infinity. And then the axis of symmetry, x equals 1. Get the x-intercept. So for the x-intercept, you let y equal 0. And if you don't have to use a quadratic formula, please do not. Okay, it just increases your probability for error. So you're always trying to factor these things if you can. And 3 and 5 seems to do it. So x will be negative 3, so negative 3, 0, or x is 5, so 5, 0. The y-intercept is usually pretty easy. If you just plug in 0 for x, you get y equals negative 15. So 0 and negative 15 for the y-intercept. And then finally, you can go to your graph. Looks like we need a lot of room in the third quadrant, or fourth quadrant. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then there was a y-intercept at negative 15 there. The vertex is there. The axis of symmetry is zipping through the vertex. We have 1, 2, 3, an x-intercept there. 1, 2, 3, 4, 5, x-intercept there. And that should be good enough to graph it. Okay. One more of these. This next one is the video quiz, 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 video quiz. I think it's the second homework and video homework 7. I think the second problem, and or is this the third problem? This will be the third problem in video homework number 7. Okay. Then there will be one more from 11.4. Okay. So, identify your shape. So A in this case is 1. It's greater than 0, so it's happy. Secondly, the vertex. So the h coordinate is negative b all over 2 times a. So negative 4 over 2 is the same as negative 2. Then plug that back into the equation to get your y value. So negative 2 squared is 4. Plus 4 times negative 2 is negative 8 minus 1. So I get negative 9 plus 4 is negative 5. Okay. Domain is always negative infinity to infinity. Range, because it's happy face, it'll go from negative 5 to infinity. And the axis of symmetry, x is negative 2. Okay. X-intercept, you let y equal 0. So I get 0 equals x squared plus 4x minus 1. And sadly, I can't factor that. So you have to use quadratic formula. So a is 1, b is 4, c is negative 1. So x will be negative 4 plus or minus the square root of 16 minus 4 times a times c all over 2 times a. Okay, so this will be negative 4 plus or minus the square root of 16 now plus 4 all over 2. So that would be negative 4 plus or minus square root 20 over 2. So negative 4 plus or minus 2 root 5 all over 2. And you can simplify that, negative 2 plus or minus root 5. And then I'm going to get some approximations to graph it, 0.24 or negative 4.24. Y-intercept, much easier, just let x equal 0, so y will equal negative 1. So you get y-intercept 0, negative 1. Okay. Okay, let's go over and try to graph it. Going to be mostly in the fourth quadrant, I guess. No, the third quadrant. So negative 2, 1, 2, 3, 4, 5. Y-intercept at negative 1. X-intercepts at 0.24, which is about right here. And then negative 4.24. 4.24 right here. And then the axis of symmetry goes to the vertex at negative 2, and then we should be able to graph it. Okay. Okay. So graphing. One of the applications of parabolas is to maximize and minimize, and that actually turns out to be an application that we want to do a lot in math. Just maximizing or minimizing something, maximizing profit, minimizing casualties, all of that. Okay. So basically, if you have a happy face, then there is a min. A min at the x coordinate of the y value. So the actual min value is the y value, okay, not the x value. If you have a sad face, then guess what? You have a maximum. Then there is a max at the x coordinate of whatever the y coordinate equals. Okay, so let's look at one of these when they're throwing a ball of some sort, and then we'll come back and then we'll go online and do my math lab. Okay, so some applications. Actually, this is probably on. Let's look at the application of my math lab rather than. Seems like that's more satisfying. Okay, so this is 11.3 now. I think this is 11.3. Yeah. Got rid of that one. Okay, here's one. Person's on a 100-foot building and they throw a baseball upwards. The quadratic function given models the ball's height above the ground, s of t, in feet per second, t seconds after it was thrown. So the formula, s of t equals negative 16 t squared plus 128 plus 100. Okay. S of t is height, and that's in feet, and then t is time after thrown. Okay, so how many seconds does the ball, and after how many seconds does the ball reach its maximum height? Okay, so this is a question about the vertex. So the h coordinate of the vertex will tell you when the ball hits the maximum height, and then the y coordinate of the vertex will tell you what the maximum height is. Okay, so h will be negative b all over 2 times a. I'm going to need a calculator. So basically 128 divided by 32. That's 4. Okay, I'm going to plug that now into the S formula. So I'll have, let's see, negative 16 squared plus 128 times 4 plus 100. Okay, so its height will be 168 feet. And I know I lost my x back here. Okay, so the maximum height will be 868 feet, and that happens after 4 seconds. Uh-oh. Oh boy. Negative b, did I get that right? Over 2a. So that should be a t, not an x, first off. Okay. So negative is 32. Oh, I see what I did. No, it should be negative 16 squared. It was being helpful, and it ruined my answer. Negative. Okay, so plus 128 times 16 plus 100. Sorry about that. So it looks like 1892. Seems like it should be worse. I just made it. let me try it again. I'm going to have to get my calculator out because I'm so bad at this calculator. Anyways, so I'm putting in 4, right? So that'd be 16. So 16 times 16 is 256. It's negative. Okay. And then plus 128 is times 4, not 16. And then plus 100. All right, that seems better. 356. Okay, let's try that. If not, I'm going to have to get my own calculator out because I hate that calculator online. Okay, excellent. How many seconds does it take for the ball to finally hit the ground? So when it hits the ground, the height at that point will be 0. Okay, so what it's asking you to do is to let s of t equal 0 and solve for t. Okay, so let's do that. It's got negative 16t squared plus 128t plus 100 equals 0. And here you could use a quadratic. You could try to factor it. Probably everything is divisible by 4. I just hate getting this stupid calculator out. It's probably divisible by 8. All right, so I'm going to pull out a negative 8. And I get 2t squared minus 16t plus, I don't know. There's the issue. The stupid guy right there. So I can only pull out a 4. Negative 4. So 4t squared plus 32t plus 25 equals 0. Let me just make sure. A little gun shy after what just happened. 32. 4 times 5 is 20. Yeah, so 5 and 5, and then 4t plus, make sure it works, 20 plus 5. Whoops, that doesn't work. About 20, about 10, 10. I may have to just go to the quadratic. It's a very sad day. Quadratic. Bummer. Alrighty then, so I can use this for my quadratic. I don't need the negative 4 part, assuming I factored correctly, which I apparently didn't. Okay, so I needed to pull out the negative. So maybe that will change things and I can actually factor it. I doubt it though. No, I'm still not able to factor it. So forget all that. Let's just be safe and go back to the original. X equals negative 128 plus or minus the square root of b squared. Jeez, 128 squared minus 4 times a times c all over 2 times a. Okie dokie. I am going to my calculator this time. I'm not going to use that online thing. 28 plus or minus square root of 128 squared. That'll become plus 4 times 16 times 100. So the insides are 22784. All over negative 32. Let's see if that's even square rootable. And no, it is not. So we'll have to get some approximations. Negative 128 plus this answer divided by negative 32. So one of them is negative. I can throw that one out. It's not going to be a negative answer. And the other one, 128. Well, that was the one answer. All right, well, anyways, 128 minus square root of 22784 divided by negative 32 is 8.71699. Okay, round to one decimal, so 8.7. For s of 0, what does that mean? S of 0 is the height at time 0 before you throw it. So, and because the person's standing on a building, it says the building is 100 foot tall. If you plug in 0 for t, you get 100, and it makes sense because the person's on a building 100 feet tall when he first throws the baseball or whatever. Then they want you to graph it using all this information. Okay. So B and C are out because those are in the second quadrant. Okay. So it's either A or D, and the maximum height was 356, and D doesn't go above 200, so it has to be A. And that's it. Okay. How did I know that it had to be in the first quadrant? Well, these story problems are always like that. And you could also tell from the intercepts. If you can't really see it here, but let's see if I can open it up more. There we go. So the intercepts should be at 0. Sorry, they should be at negative, and I didn't write down the other one. Negative 0.71. Or 0.72, I think it was. These things where y is equal to 0 are the intercepts. Okay, so one should be at negative 0.72, the other one should be at positive 8. And if you look at the ones in the second quadrant, part B and answer B and answer C, they go out to negative something, negative 8 something. Right? This one's like negative almost 9 something. So there's no way these two answers could have been correct. Okay. This is kind of like a weird back engineer the equation of the parabola. So it has the same shape as these graphs, but with the given minimum. So the minimum, remember, is going to be the vertex. It says the minimum is the x coordinate is 15. The minimum is 0. Minimum means it's a happy face. So, right, it has the same shape as the graph of x squared or negative 2x squared. Let's just go y equals, it has to be happy face, so it has to be 2x squared. But I'll put the x minus the h coordinate plus the k coordinate, which was 0. See if that works. I should have got rid of this question because it don't make any sense. I'm going to say it. Let's see if that works. Yeah. So, I mean, it's basically, I sort of just borrowed this part, and because it's U-shaped up, I took this one, and then I kind of just put it into the form 2 times x minus h squared plus k, where the vertex h comma k in this case was 15 comma 0. So I put the 15 in for h and the 0 in for k. Here's another one like that. So it has a maximum, so it's a sad face, so it has to be the negative 6x squared thing. So negative 6 minus h squared plus k. So h of x equals that. And then the vertex has to be negative 2 comma 9. So we're looking at negative 6 times x minus negative 2 will be plus 2 squared, and then plus 9. It's helping me out with extra parentheses that I don't want. Okay. So hopefully that's kind of obvious what they want. This is kind of the same deal. So you're going 3 times x minus h squared plus k. And they're giving you the vertex negative 11, negative 3. So our formula, g of x will be 3 times x minus negative 11 will be plus 11 squared minus 3. Oh, I did not know these questions were in here. It's plus 11 squared minus 3. Same thing. Give the domain and range. So based off the maximum is 8 comma negative 6, and it's a max, so it's like this. So the domain is always the same, negative infinity to infinity, and then the range will go from negative infinity all the way up to the y coordinate of the vertex. Okay, so the domain, negative backslash inf comma backslash inf, and then the range negative backslash inf to negative 6 bracket. Oops, wrong kind of bracket. There you go. Okay, so I think we can handle these then. Okay, that'll do it for this section. As usual, thank you for watching, and we shall see you next time.